Good morning.
Good morning.
See my pie. Good morning. Okay, it's time to begin. What we're going to be doing today, tomorrow, is we will begin on a full chapter review of the material in section 2.8 and also uh, chapter 3, excluding section 5. So we're going to go to that. Some of the problems will be the same ones that I went over in class. Some of them will not. Couple of the problems that I went over in class will actually be on your exam 3 test, the same exact problem. So with that, let's get started and go to the review pages. So here we go. We're starting with section 2.8. Okay, the rules for operations. If you're adding two equations, you just simply add x's with x's, x squares with x squares, and so on. Same thing if you're subtracting them, multiplying them, which would be distribution and division, either canceling or possibly you could use synthetic or long division if you needed to. Some examples of this operation. Okay, if we have the first equation is x squared minus 3x plus 1. The second one is square root of 8 minus x. The third one is 2 over x plus 1. Then it asks us to evaluate. When it gives us a replacement value in the equation, then we want to do that first. So if we just find the value of f of -3, we replace the x squared, the x with -3 in each location and evaluate it. If they replace the g equation, the x's with 4, then we replace the x with the 4 and we get 2. In the case of f of a plus 1, we replace all of the x's with a plus 1. So we have, this was x squared, this was x. Now you have to FOIL that, getting a squared plus 2a plus 1, and then distribute the -3, bring down the 1, combine like terms. Here, f of 10, okay, we replace the x with 10 and we get a -2. your answer is undefined, or we could simplify it to square root of 2i, or I square root of 2, but for the sake of this, undefined is an adequate answer. Here we have f minus g and of -8. So we're taking the f equation, okay, and we're replacing all of its values with -8, gives you 64, gives you 24, gives you 1, and then minus the g equation. So we replace the x with 8, and we get 0, okay, because, oh, wait a minute, -8, we get 16. So that's, I need to fix that. Oh, so this would be 4. Okay, now that all equals 85. Okay, on number 6, we're going to multiply these two if x is replaced by 0. So g, if x is replaced by 0, we get square root of 8 for g. And f, we would get, that's 0, we would get 1. Okay, so in this case, we would have our h rather we're looking at. So we would have 2 over, here's my square root of 8, and here's 2 over 0 plus 1 right there. And that would give us 2 square root of 8. 8 breaks down into 4 times 2, extract 2 out of that, giving us 4 square root of 2. Number 7, in this case, we take h and replace the x with -1. We get an undefined value. In these problems, we have to tell the domain, okay, of whatever it asks for. So if we take r, x squared plus 3, and subtract t, x plus 4, okay, so we have the first one, r minus t. We distribute this negative and then combine like terms. Well, this is a parabola, okay, with the y-intercept of -1. Okay, and the vertex of, or the line of symmetry rather, being, well, let's see, that's a -1, so it would be 1 over 2 times a 1/2. Okay. Now, infinity to infinity here, x can't be 0. Anytime you have a fractional one, for finding the domain, you don't need to be concerned with the numerator. You only need to be concerned with the denominator. Since x cannot be -4, that's an equal sign and a not a plus or minus. Then that gives us these two disclaimers with a gap. So it won't be inclusive of 4. So I use the parentheses. Okay, here I'm multiplying these, 2 over x, and x plus 4 gives me 2x plus 8 over x. That could be simplified a little bit, but it's not necessary. The important thing we need to know is x cannot be 0 in this part of this. X can be anything up here, but X can't be 0 down here. So that puts these two limiters right here, can't be 0. So there's a gap at 0. We weren't required to do different quotients. And in this case, we want to compose these. What this statement right here means is we're going to take this G equation, which can be defined as G of X, and we are going to use that as a substitution value into everywhere there's an X in the F equation. In a sense, this is kind of like what we did up here, where we used the A plus 1 as a substitution into every X. It's a very similar process. So here's the X squared, which we've replaced the X, and the X right here, we've replaced that. We simplify this, we have to FOIL that, we get 25x squared plus 40x plus 16. Here we get negative 15x minus 12, and we bring down the 1. Now we combine all like terms, ending up with 25x squared plus 25x plus 5. Now we're going to reverse this process. So in other words, we're going to take this quadratic formula right here, and then we're going to substitute it into that x in the G equation. Okay, so we're going to take this and substitute it into the G equation. So I've got 5 times x plus 4. Okay, or I should say 5 times f of x. I distribute that 5, combine like terms, and I get 5x squared minus 15x plus 9. Problem number 14. Okay, this time I'm taking G into F. So I'm going to replace the x's with this x squared plus 5, square root of x, square root of 5x plus 5. So in my original equation, I've got 5 times substitution squared minus 1. Well, this square root of 5x plus 5 squared is just 5x plus 5. So now I distribute that 5 out front, getting 25x plus 25 minus 1. And I simplify that, the 25x plus 24. I'm reversing order this time. This time, here is my fundamental equation, and I'm going to replace this x with that phrase. So I did that here. I distribute, simplify. I get the square root of 25x squared. 25 is a perfect square, gives you 5. Square root of x squared is just simply absolute value x. Okay, here we have a rational one, so we've got to look at any values that we can't use. So we can't use positive 4 because that would give us an undefined value. So we do G of 9. Okay, so I take 2 times 9 minus 8, which gives me a value of 10. So G of 9 is equal to 10. So then I replace that 10 sequentially into the F equation right here. simplify it, and you get 1/2. When we reverse, we're going to reverse the order, and we're going to use a different substitution value. So I replace, here's 3 over x, the replacement, minus 4, okay? And that gives us 3/2 for f of 6. Then I take f of 6 and put it into g of x. So here I replace this x with a 3/2. I simplify, and I get -5. Better leave that there just another moment. Number 16. Okay, we've got we can't we can't use values of -2. So here we've got this. This time we're just going to use values. Excuse me, my allergies are going nuts today. That'll be a lot of fun at the dentist in a little bit. Okay, so anyway, we're going to take the f equation and we're going to replace the x's with the g values here. So I replace this x in the denominator with 3x minus 2. And I start simplifying it. I get 3 over 3x, which I simplify to 1 over x. Now, in this case, I had the value of x equals -2 that I couldn't use. And because of this one, I also have the value x cannot be 0. So this is going to be a 3-way here. We go from -∞ to -2, not included. We can't include that. Union with the -2 to 0, which is our next stopping point that we can't include, and then 0 to +∞. So we actually have 2 gaps in this equation, one at -2 and one at 0. And those gaps, by the way, are called asymptotes. Okay, let's go on. And we could do these, but we're not going to do these because this is asking us to decompose. Okay, estimate the function values from the graph. F minus g of 3. So first thing we do is we look up f of 3. Okay, if f is 3 or x is 3 on the f equation, 1, 2, 3, we go up from here, and we see that if x is 3, then y is 4. That's where this 4 came from right here. Now we'll do the same thing with the g equation. If x is 3, then y is 3. So here's that value. So 4 minus 3 is 1 because we're subtracting. Now we're going to do a similar process, dividing when x is -2. So we go to the g equation. X is -2, 1, 2, and that gives us a value of -4 right here. Now we go to the f equation at -2, and we get +2 right there. Simplify this, and we get the overall answer of -2. Question number C. G compose f of 1. Okay. So first thing we do, we find f of 1, and we go up right here, and we see that the y value is +2. That's where this 2 came from. Now we're going to replace that 2 into the G graph. Okay, if X is 2, we go up and find we have a value of 4. Okay. I'm barely going to be able to reach this. I may have to jump back and forth. Okay, F composed G of 3. Okay, so we find the G of 3 right here, 1, 2, 3, and go up, and it's 3. And of -3. 1, 2, 3, and go down. Okay, which is -4. Then we take F of -4, 1, 2, 3, 4 on the F equation, then would be -2. Okay, on this one, we find F of -3, F of 1 to -3 is 0. Okay, F of -3 is 0. Then we substitute that 0 into the F graph again and see what Y is when X is 0. And the answer is 2. Okay, graph quadratics in vertex form. Okay. Now, vertex form is what we've got here. Okay, if it asks for vertex form, this is standard form. Okay. Now, if this A term here or here is positive, greater than 0, then the graph will open up. If that A is negative, then the graph will open downwards. Okay. Now, in vertex form, the H opposite of sign will be 2 things. One is it will be the X value, okay? This will give you that'll give you the line of symmetry. Now, so in this case, would be like that down through the center. This case, like that down through the center. Now, if you take this value, the opposite of sign, okay, and substitute it into the original equation, then you can get the Y value, which this is the Y value of the vertex. Now, here's one. A is 1, so it's a non-player. +3, 9, -9 is the vertex right down here. That's the line of symmetry. This thing opens up because A is positive. Now it asks, what are the X and Y intercepts? Well, the Y intercept is if you replace all of the x's with zeros, then what do you get? Okay, you replace this with 0, you get -3 squared, which is 9 minus 9 equals 0. Here's the work on that. And so the y-intercept is 0, 0. You can see it in the graph. Now, for the x-intercept, you replace y with 0, or in other words, replace the f of x with 0. So we've got this. Take the 9 on the other side. They didn't show it, but take square root of both sides, plus or minus, and you get that, which gives you the points 6 and 0 here and here. The y-intercept and the x-intercept are one and the same in this case. Okay, we said the axis of symmetry was here, which is where x is 1, 2, 3. Where did we get that? This value opposite of sine. Okay, problem number 2. This time we have a negative a, so this thing's going to open downwards. The line of symmetry is going to be x equals +2. 1, 2, you can see line of symmetry here. Okay. To find the y-intercept, we replace this x with 0, and we get -2 squared is 4 times a negative is -4 minus 1 gives us -5. Okay, right here's the notation on what I just said. So our y-intercept is 0, -5 right here. Now, we can find this point by its 1, 2 places to the line of symmetry, so 2 more places would give us another point right here. Okay, that's easier than doing an XY table. There is no x-intercept on this one because it opens downwards and the vertex is below the x-axis. Now we've got an equation in standard form, and it tells us to put it in vertex form. Well, I've taught you that to find the line of symmetry and the x value on an equation like this, you use -b over 2a. Well, that gives us -20 over 4, which is -5. Okay, so that means the line of symmetry is x equals -5, which is the first value of the vertex. Now we take that -5 and substitute it into the equation, and it gives us -8. So the vertex is -5, -8. Based on that, -5, opposite of sine, bring down this value, and that gives you the vertex form. Now, you noticed here we had a 2 here. So A is 2, and A is 2 on the final form. Okay. Now, in terms of finding the x and y intercepts, the y-intercept is easy. It's 42. To find the x-intercept, we can replace y with 0 and solve this thing. So take the 8 on the other side, divide both sides by 2, and we get 4 equals x plus 5 squared. square root of our x plus 5 squared. I need to take the square root of this and take the square root of this, plus or minus. So we get plus or minus 2 equals x plus 5, which gives us the value -3 and -7. By the way, there is another way of changing an equation from standard form to vertex form, and it's called one of our factoring methods that we use, and where you find perfect squares on both sides, and it's a pain, and it's not required on this course. Okay, here's another one. In this case, a is -1. Okay. If we use x equals -b over 2a, we get x also equals -1. So -1 is the x value of the vertex and also our line of symmetry. We substitute in -1 into the equation, and we get +4 for the y value of the vertex. Because that's negative, this opens downwards. The y-intercept is 0, 3, right over here. So we've got this point, that point by symmetry. Okay. Now, in order to find these 2 points, the x-intercepts, we let y equal 0. Oh, by the way, if this point is the point -1, 4, that gives us the vertex equation, opposite of sign 1 and same sign 4. We replaced y with 0. Okay, solved it, and we got the values of -3 right here and +1. Now, one more thing, it asks us to write the domain and the range. Well, the domain, because these go outward forever, is infinity to infinity. The range, you always start from low to high. So you start at -infinity, and you go up to a high point of y equals 4, which also can be called a maximum. This question is a discriminant problem, basically. Okay, you have these 3 choices, A, B, C over here. To determine the discriminant, you use what goes under the radical on the quadratic equation, b squared minus 4ac. If you put the numbers, the a, the b, and the c into this, if you get a negative answer, then you have no x-intercept. It's going to be imaginary. If you have a positive perfect square answer, then you're going to get 2 intercepts with the positive and negative. If it's a positive non-perfect answer, non-perfect square answer, then you're also going to get 2 x-intercepts, but you're going to have radicals in. And if you get 0, then you have exactly 1 intercept, which will be the -b over 2a. Okay. Find the vertex of a parabola by using the vertex formula. Okay. Here's the vertex formula, the first part of it. We've already talked about this, negative b over 2a. That finds the line of symmetry, and it also finds the x value of the vertex. Then you substitute that into the equation to get the y value. Okay, here's the equation. Determine the vertex from the formula. So we take the negative b over 2a, gives us negative 48 over 2 times negative 3. Simplify that and you get positive 8. So 8, x equals 8 is the line of symmetry, and 8 is the x value of the vertex. Now we take that 8 and substitute it into the equation, and we get 27. So our vertex is the point 8, 27. Now, in vertex form, this problem would be negative 3 brought over for the a value, 8 opposite of sign, and 27 in vertex form equation. Here was just a word problem that we actually went over in class. Okay, we're going to determine end behaviors. All of this is math speak on what qualifies. Now, here's the real stuff. If your first term, the x power is even, then both ends will go up or both ends will go down. If a is positive, both ends will go up. If a is negative, both ends will go down. Over here, if the power of the leading term is odd, if a is a positive number, it'll go from low to high, although it may take some bumps in the middle for fifth, seventh, ninth degrees, and so on. If it's an odd power and a is negative, then it'll go from high to low, even though it might have to go through some undulations. Okay, given that information, we look at this equation. A is positive, and it's an odd power. Because it's an odd power, then it's going to go from low to high. In this case, A is negative, and my leading term would be x cubed x fourth. So even. So even, I'm going to have a W either up or down. And in this case, because the A is negative, it'll start down and it'll end down. Zeros and multiplicities. Okay, for when we find zeros, in other words, the x values on a graph, we need to determine whether they're touch and go or whether they're crossing in order to be able to graph them. Now, just to find the zeros itself, then and another root for zeros is roots, okay? We need to factor the equation, or depending on the degree, use long division or synthetic division. We'll talk more about that in a few minutes. In this case, this will factor by grouping. Okay, here's the equation. I group the x cubed and the negative 5x squared, and I factor in x squared out of both of these two. Then this business, I factor 16 goes into 80 exactly 5 times. So I factored a negative 16 out of both of these, and I get negative 16 times x minus 5. Well, you notice I've got x minus 5 both places. So I factor it out, leaving x squared minus 16. X squared minus 16 is a conjugate, so you could get x plus 4 or x minus 4. Either way, it'll ultimately come down to the zeros of plus or minus 4. The x minus 5 gives us the 0 of positive 5, always opposite sign. Problem number 4. Okay, now in this case, here's my equation. These are not A, B, and C constants. What I'm referring to is here I have the first x term, the second x term, the third x term. Now, in this case, this one is going to produce a root of x equals 0 when you use the zero properties rule, okay? This one will produce x equals positive 1. This one's going to produce x equals negative 3. Now let's look at the multiplicities of this. Well, there's a first power hidden behind this x, so it's multiplicity 1 because it's an odd power. There's an even power on this one, so it's multiplicity 2. It's going to be a touch and go. The multiplicity 1 is going to be a crossing. And for the third one, because there's an odd power here, multiplicity 3, then that means that this will also be a crossing 0. Now, what do they have on the graph? 0, multiplicity 1, so it's crossing. 1, multiplicity 1, so it's crossing. Negative 1, negative 3, I mean, right here, and it's crossing. This is not the same problem we had before. Earlier, we had a second power behind this parentheses, but this is a totally different problem. If that were a positive 3, then that would have to be a touch and go, and this would become an even with up and up. Okay, problem this one. Okay, here we've got a crossing 0 at 0. Here we've got a touch and go at positive 1 right here. From this 0, it goes up a little bit, back down, touches, and then goes. And here we at negative 3, we have a crossing 0 also. You can see our, you can see our ending patterns. Okay, over here, I've got a crossing 0 at 0. I've got a crossing positive 1. I've got a crossing, no, I've got a touch and go at negative 3 because I have a total of 2, 3, 4th degree. Then I have to have the up and up or the W shape. Okay, so here I go up and up from these outward points, and you can, how would you get this maximum and that relative minimum there? Well, you'd have to use an XY table. Okay, this is just going over what I just said. If it's an odd multiplicity, it will cross. If it's an even multiplicity, then it will just touch and change directions or touch and go. Okay, there is a rule on turning points. The turning points rule is whatever the degree of the equation. For example, if it's x cubed, then the graph will change directions up and vertically up and down at most 3 minus 1 times or 2 times. So this thing's going up, turns here once, turns there twice. Sketch a polynomial. Okay. First, we look at what leading terms do for us, whether it's like that or whether it's like this or like this. Can't hardly see that in my screen. I'm too close. Then you find the y-intercept. Find any real zeros. Plot the x and y intercepts. It may or may not, depending on if it's a quadrilateral, find the vertex. And then start the beginning and ending directions, and then fill in the middle. If you have to use XY tables, you can. Okay, so let's sketch this one. Need to raise that up just slightly. Okay. What's our total degree? 2, 3, 4. So this thing's going to be W shaped. Here's our general shape with a 4th degree equation. We're going to have at least, at most, 3 terms. Well, let's look over here. 1, 2, 3. 3 terms. Okay, for our intercepts, okay, if we let x be 0 in all of these, then we'd have -1 squared times 3 times -4, okay? And that would give us a value of -12. So our y-intercept in this case is -12. Notice our scale here. This is not the same scale up and down as it is sideways. Each one of these squares is 10. Okay. Now, if we want to find what these are, here we've got at +1, we've got a touch and go. At -3, okay, right here, we've got a crossing. And at +4, we also have a crossing. First, we draw these 2 ending lines. Realize that this is crossing, so we go down a ways, then up to the touch and go point, through the y-intercept point, down to another minimum, and then back up here and upwards bound. Now, how low does this go and how low does this go? You got to do an XY table to figure that out. Okay, number 8. Okay, there's a power there, so I can't hide that. What is my total degree? Well, it's 2, 3. Okay. Now, my leading term is negative. So this means this is going to go from high to low. And at most, we can have 3 minus 1 is 2 terms. So let's find the intercepts. First, let's find the y-intercept. Replace x with 0, you get 1. Replace x with 0, you get -3. You square the -3 times 1 times a negative, and that gives you -9. And so 0, not -9 right here is your y-intercept. Okay. -1 is a 0. +3 is a touch and go 0. So we know we're going to cross here. We know that we're going to touch and go here. We know we got to go through this point. And we know that this thing has to go from high to low. So we start here. We come to the -1 through the y-intercept up to the touch and go point and back down. And with that, that's all we're going to get done today. So tomorrow we will begin our review on section 3.3 and continue after we finish doing this review on 3.3. Then we will do a actual test review with citations. So with that, I'm going to close the sharing. If any of you, where could I find the review worksheets? I decided not to send them out this time, but what we're doing right now is going over. Then tomorrow, like I said, we'll go over what you should expect on the test. Are there any other questions? Now, tomorrow I'll be back in the classroom. Business as usual. If you want to come, you can. If you want to do it online, that's your choice. Wednesday will be exam number 3, and that is in person. So you'll need to be there for that. Well, if there are no other questions, that'll be it.